Welcome to the session on flowcharts. This session is specially designed for CA Inter students. I am Swati from Hyderabad. Before we can go with the definition, let us first understand why is the flowchart important for us. If you automate, all your works will happen very fast and the reports will be instantly generated and decision can be quickly taken. Okay? So we will get obviously more than double the benefit. If you want to automate your client business, then you have to give your requirements to a programmer. Okay, there are thousands of software development companies in the market. You can approach any one of them. Now you have to give your requirements to a developer. Who is supposed to give the requirements? Business analyst. Business analyst communicates the requirements to a developer. I think a chartered accountant can better understand your requirements and better communicate to the developer. So in simple, a chartered accountant can be a very good business analyst to give your requirements to a software development company. There are different ways to communicate. Documentations. Developer can go through the files and understand a bit. But documentation itself may not be sufficient. You can also have an interview. Give all your requirements. Developer can understand it better, but if we can represent our requirements in the form of a picture, drawings, that will be more clear. To give our requirements in a picture form, we have to use flowcharts. Okay, flowcharts are the pictorial representation of a program. Whatever software you want to develop, you give your requirements in a picture form so that the developer can easily understand and can create a software without any faults in it. Flowcharts helps not only in giving your requirements to a programmer, but also helps an auditor in his system audit. Auditor is important before we create any software, during the software development and after the software is developed. His role is important before, during and after the system is developed. In all these three stages, auditor will be using the flowcharts for checking. Let us see the definition of a flowchart. It is a pictorial representation of a program. Generally, a software is set of programs. If at all we have to draw a flowchart for the complete software, we have to connect all the program flowcharts together. Output of one program goes as input to another one. So this is how we can draw a flowchart for the complete software. Okay, once again I will repeat. Flowchart is a pictorial representation of one program, of a program. Let us first go through the symbols used in a flowchart. We'll be using only these symbols in our flowcharts. Maybe in your books you might have come across other symbols like display, print, maybe some other symbols are also there, which are actually not important for now. If you observe, display and print are related to output. Okay, so in our flowcharts we'll be using only these symbols: start, stop, input, output, process, initialization, decision or condition, links and connector. So in our flowcharts we are dealing with only these symbols, standard symbols are enough for drawing any flowchart. Let us understand one simple program in our software. Okay, let us consider this add software is a program to add any two numbers. Whenever we want to add any two numbers, we will double click on that icon. Open the software. After we open the software, we have to give some input into these fields. Then we'll click on the submit button. Then some processing will be done and the system will give us some output. Okay, once you get the output, you can simply close the software. Okay, now whatever we did just now, we will do the same thing using our flowcharts. At the bottom of this system you are finding a table. Consider that one as a memory locations. Consider that one as a memory locations inside this computer. Now let us open the software. Opening a software is represented by a start symbol. Once you open the software, you will get this screen. Okay. Now in our flowchart, immediately after the start, we have to write clear working area. Clear working area means all the memory locations should be set to 0. Clear the working area. Okay. I will make you understand this clear work area in our next example. You will understand it better in our next example. Okay, now we have to give some input into the system. Okay, let us enter some value for A. Okay, we have to represent it in the flowchart something like this. Input A. Whatever you type in this text box, that will get stored in one of the memory locations. 10 is stored in the memory location and it has some name A. Now enter the value for B. 20 got stored in another memory location and that memory location now has the name B. Now we'll click on the submit button. Okay, something should get processed. Whatever is there in A and B, these two values should get added and that value should get stored in another variable with the name sum. Okay. So 30 got stored in our memory location and that memory location now has the name sum. Okay, now system should get print this sum onto our monitor. Yes. Now, yes, display sum. In the flowchart, we have to represent it using display sum. Okay. Once you get the output, you can simply close your software. Closing the software is represented by the stop. Now we'll try to understand what is that clear working area with this example. Now consider this program 2 is the second program in the same computer. I'll show you the flowchart. Can you tell me the output for this? Say the value for A is 100. If A is 100, what is the output? Yes, we did not give any value for B. Has to take it as 0. Okay, the output here should be 100. But unfortunately, in our program, the output is 120. System is taking 100 for A and for B, it is taking the value from the memory location. Okay, the value for B is 20. So it is taking 100 plus 20 and giving the output as 120. Okay, which is actually wrong. If you don't give any input, system has to take it 0, but the system should not take any value that is there in the memory locations. So here comes the clear working area. Before we can begin any program, we have to remove the contents from our memory locations. That is, we have to clear the working area. CWA. So clear work area should come immediately after the start symbol. Now we'll see how this flowchart works. We will open the program start. Okay. Now after clicking on the start button, we have to apply clear working area. Clear working area will clear all the memory locations and also the names assigned to those memory locations. Okay. Now you can give the value. Calculations is done. You can now display this result on the monitor. Display sum. Yes, once you get the output, you can simply close the software. I hope this flowchart is understood clearly. Can you pause your screen and draw a flowchart to display sum of any 3 numbers? If this is the flowchart you have drawn, then correct. Please pause the screen and try. We'll see the flowchart now. I hope you got it right. Let us try the next flowchart. Please pause the screen and draw a flowchart to find out the simple interest. Find out simple interest. Okay, give PTR as input. Along with this flowchart, you should also mention what is P, T and R and also SI. This is very important to mention the variables. Okay, somewhere on the flowchart, somewhere near the flowchart, you have to mention what are the variables for. Draw a flowchart to find out whether a number is even or odd. You can pause the screen and try. Let us begin this flowchart. So we'll start a flowchart with the start symbol. Immediately after the start comes a clear working area. No one. Now we have to find out whether a number is even or odd. Okay, you can give input n. N can be any number. Okay. Now we'll use a condition box. If n is divisible by 2, if n is divisible by 2, if yes, we will display it is even. Otherwise, it is odd. Once you get the output, you can simply use the stop symbol. Now, if you observe in this flowchart, there are two print symbols. Generally, in any software, only one output will be there, but in this flowchart, you can find two print symbols. Yes. So, whenever system is giving any output, either it will print even or it will print the odd. Okay, flow will be only in one direction. Every output should get connected to the stop symbol. Okay, so remember that none of the symbols are left open. Output symbol, we will connect it to the stop like this. Okay, now the flowchart is complete. Now let us draw a flowchart to find out the greatest of any two numbers. Greatest of any two numbers. Something like 2, 3, 3, 4, 8, 6, 5, 5. Find out the greatest of any two numbers. Okay, so we have to first start with the start symbol, clear work area, and then we have to give some input into the system. So we'll give any two numbers as input, A and B. Now we'll use a condition box. You have to first check if both the numbers are equal. If A is equal to B, then print both are equal. Otherwise, check if A is greater than B. If A is greater than B, then we can say A is greatest. Otherwise, B is greatest. Once you get the output, use the stop. And remember to connect all the output symbols to the stop like this. Okay, your flowchart should be very neat. There shouldn't be so many lines connecting to the stop symbol. If you observe in this flowchart, there is only one single line getting connected to that stop symbol. Okay. Now this is a flowchart to find out greatest of any two numbers, right? Any two numbers. Can you draw a flowchart to find out greatest of any three distinct numbers? That means no two numbers are same. All three numbers are different. Find out the greatest of any three numbers.